Okay, welcome back. What I want to look at this evening is something called bells and buzzers. Now, the reason why I've chosen to look at this is something that many moons ago, if you go to a hotel, you would find these things very commonplace. And if you rented a room in a hotel, when you press the bell in your room, what would happen is that it would ring a bell downstairs in the reception area. Within the reception area, you would be able to identify which room had been, I should say, which room had pressed their buzzer or pressed their push button. And you can identify each room in turn simply by that method. All I want to do is to show some probably old-fashioned systems that were in place at that point in time. But it's always important to remember or have a look at where we're coming from. Okay, so here, bells and buzzers, okay? The operation of bells and buzzers is identical, and units of these types are used widely to give audible warning. There are various types of bells. Now what I want to look at is the single stroke bell. This has applications where simple signaling is necessary. It consists of an electromagnet which, when energized, attracts a soft iron strip called an armature. Now against the pull of a flat spring strip. Now the flat spring strip acts as a tensioner, so it holds it in one position against the magnetic pull of the coil when it is energized. Now a striker supported by the armature sounds the gong, figure 7.1, and we'll come to those figures later on down as we proceed, okay? But always look back at what the figure refers to. Excuse me. When the current is switched off by releasing the signaling push, the spring strip returns the armature to its original position. Excuse me, sorry about that. Now here we have what's called the Trembler bell. Trembler bell. This is the most widely used type and is similar in construction to the single stroke bell, but has the addition of a set of contacts, P. Now when you look at the diagram, look for this letter P because it is identified on the diagram itself, which are opened by the movement of the armature towards the electromagnet as shown in figure 7.2. This de-energizes the magnet and allows the armature to return to its original position, closing the contacts and repeating the cycle. So it's a trembler bell, so once you keep the button pressed, that trembler will continue to ring and activate the bell until you have released the buzzer. Okay? Now, while the supply is maintained, the armature is in a continual state of vibration, its striker hitting the gong repeatedly. The rate of striking depends on the flexibility of the spring strip and the weight and size of the moving system. And here we have what's called the continuous ringing bell. It should be continuous ringing bell, okay? I seem to have missed my ing out of here. Okay, so I do apologize for that. Now this is a particularly useful for alarms system, since it will continue to ring after the external operating circuit has been broken. So although you've broken the circuit, this system, continuous ringing bell, will continue to ring even though you have broken the circuit, because it is an alarm system. This construction is shown in figure 7.3. Includes a relay arm which drops when the bell first rings, closing an internal operating circuit which continues to ring the bell until it is rested by lifting the relay arm to its original position. This can be done by means of pulling on a pull cord or by remote control. Okay. So what he's saying here is that with this kind of bell you cannot reset it. Once it's triggered, and the only way you can reset it is by having a mechanism pulling on a cord which will reset it, or resetting it by remote control, which is what you will do when you try to push the button on your alarm system. So imagine you have an alarm in your home, right? And you know you have phone numbers 1066 for instance, okay? When you put in the 1066, it will set the alarm, or it will disarm the alarm, okay? Now this is a similar thing here, okay? That's the principle behind your alarm system. Now let's look at, now here we have what's called a polarized bell. This is mainly used for telephone circuits where a low frequency AC supply is used. A permanent magnet system, figure 7.4, is fitted with two operating coils connected in series but wound in opposite directions. Alternating current will alternately weaken and strengthen the magnetic field in the side limbs, one being strengthened while the other is weakened. The moving system will thus be attracted to each side in turn, the striker sounding each bell in turn. So you're almost looking like a hammer action, moving from one side to the other, reliant upon the AC applied voltage, okay? And that comes about because, as you know, AC goes positive to negative, so it operates within that 50 cycles per second frequency. Now there are three basic types of indicator units, and what I want to look at is, when we talk about indicator units, we're looking at systems that makes you aware of an action that someone has activated in a room. So if I'm downstairs in the reception hall and I have customers upstairs in the hotel room and they want service, they will simply push a button, again similarly to what I was saying earlier, but this brings in a different kind of system into play. Now let's look at the pendulum type indicator. The indicator flag is attracted to a solenoid while the press is pushed, falling away and swinging to give indication when it is released. This is a simple and inexpensive system, but the indication ceases after time when the flag stops swinging. The pendulum type is now being replaced. Mechanical reset type indicators. The colored disc of this unit is not normally seen through the windows on the front of the indicator, but is pulled into view by a solenoid coil when the circuit concerned is energized. It then remains in the indicating position until the reset mechanical operation of a rod or lever is operated. And this is the kind of system you've seen in old style hotels many moons ago, okay? But it's always still useful to know about it, even though we may no longer use it. Let's go reset type indicator, and this is what we're looking at, okay? Figure 7.6. Let me just go back a little bit to make sure that I give an indication in regards to 7.6. Okay, that we know which solenoid we're talking about in turn and retrospectively. Now figure 7.4, 7.3, 7.2, 7.1. Okay, so it's possible I may not have come to 7.6 just yet, but nonetheless, it always pays to check and double check. Okay? And plus it gives you an opportunity to see what I have been talking about. Now I don't need to say anything further here because I've already discussed this. So let me just get back to where I was. So just bear with me for a moment. And let's go reset type indicator. Figure 7.6. Now let me just move into it a little bit so you could see it in detail. Okay. It's four-way. Now it's simply four-way because 1, 2, 3. We have 4 buttons. So you can imagine that these buttons would be in a room somewhere. Okay. And what would happen is that they would have a transformer supply in 8 volts, 4 volts from the main supply. Okay. So you have your mains wherever it comes from here, and this would then be a step down transformer. Here you have your 240 volts main supply transformer. Those are the primary windings. This would be your secondary windings. But in this case we could take off tap-ins of the transformer at certain stages to give us voltages of 8 volts and 4 volts. Okay, and these would be off fuses here. Now what this would then do is provide a supply to your buttons, and the button, and then here we have a return to the neutral or the center tap of the transformer on the secondary side of the transformer. Okay, and by pressing your button here, what it does is activates, it begins to ring a bell. So let's say we press this button here. Now this should have been labeled A, B, C, etc. Okay, but we'll just take it as button 1. You press that, and what happens there? You energize the coil. You then call this bell to ring. But that flag will move because by the energize effect of this coil will attract this flag. So therefore, if you're downstairs in the reception area, you can see that room, let's just call this room 1, has rang or has pushed the buzzer. So this room will need attention, or the customer in this room is looking for a service of some sort, okay? And that's the same effect that's been applied in each case, okay? And that would be in an indicator unit. Now the indicator unit would be placed somewhere downstairs, again in the reception area. So, and it would be someone there to see, a night porter or your night service staff. And this just shows the idea of the contactor, etc. Okay. Now this is simply showing the heating effect that is generated to control a heat source. By applying a small voltage, we can energize the coil to bring in main contacts, which will put to 30 volts to heat up your heater or your room, for instance. Okay, that's all we're saying here, that we're using a small supply voltage to control a larger supply voltage to bring on a heating effect. And this could be effectively the source of a thermostat. Okay. Right now, what I'm showing you here is this. Imagine this was just a 9-volt battery. Okay, so I've got 12 volts here, but with 9-volt battery, you know those 9-volt batteries that you can get in the shops or from Poundland. Here we have L1, L2, and L3. This is a diode, and it's a simple 12-volt diode. Okay, normally they would operate at 15, 20 volts. Okay, but what this does is it shows that it allows, if you press either of these switches here, it will only allow lamp 1 to light in this case, lamp 2 to be lit in this case, and lamp 3 to be lit in this case. What it then does, it gives out an indication that from here to here, you could put this to a bell or a buzzer. Now I said here an LED, but LEDs will just come into use, and then now much larger LEDs that's now visible and is in production, which can now be used in place of a buzzer. Okay, what it does, you see the lamp come on telling you whichever room has lit up, but then it also gives a buzzer so that you know someone has pressed a button, and it can tell you which room that will operate. So again, here we have got an updated version of what we were looking at previously. Okay, so a kind of updated version of this system here. Okay, and that's used in lamps and diodes. Now remember, these lamps themselves could even be LEDs as well, but then remember, you then need a resistor in the circuit to limit the current flowing through the LED. Okay, and you need to make sure that resistor was in milliamps. Okay. Now you remember talking about the telephone system. This is just the typical telephone relay system that was applicable. Now these were predominant, and they were systems that were taught at college at the time. Okay, and they were relevant, quite relevant to us. they may not be like this now because there could be integrated circuits that would now do this job. Okay, but the fact is that they were very, very essential in bringing and making possible events, which has led us to do other things and to develop overall. Okay, this just shows you the armature, the residual stud, what they call residual stud. It dissipates any magnetic effect that has been created within the coil itself. Okay, typical telephone relay, coil tag, etc., coil nut. Okay, what happened that when that is energized, certain parts of it will simply pull that contacts in, and that will allow other contacts to be made within this range here. Okay. Just make sure everything was in sight. Yes, it was. Okay, good. And here we have 7.4, the polarized bell. Okay. And as you can see, it just trembles between each here. You can see the movement of it, and that shows the action between it. Okay, between these two, polarized bell in action. Okay. And remember that 7.4, we spoke about it earlier, so look back at what it said in 7.4. Bear with me a second, let me see if I can just make this a little bit smaller. Okay, bear with me for a second. Now let me see if I can bring it down a little bit. Okay. Okay, yes I can. Okay, bear with me for a second. Let's try and change that a little bit more as well. Bear with me for a second while I try and get this sorted. Okay, okay, let me just get this all in. Okay, now here we have spring flip. Now let me just go down a little bit because I want to get this in, and you can see the gong again. Now look at this is 7.1, and this is just single stroke bell. Okay, and sorry about that, I'm trying to get it all in here, but let me just see if I can reduce the overall view and modify that viewing session for a second so we can get it all in. Okay. And here's where, which I've said it before, figure 7.1 single stroke bell, and I've spoken about this already. So look back at the text as to what I've said about it, okay? There we are. Now I've messed up my sheets here, I have, okay? Sorry about that, okay? Now here, again, is the continuous ringing bell, okay? And here, you can see your battery supply, okay? Internally supplied, okay? You can see your pivot, and you can adjust this acts as the trembler. By adjusting this, you can set this so it vibrates in and out against that, okay? and here you have your gong, so it will be knocking against the gong, and this gong would be metal. Okay, it would be metal, and believe me when I tell you, when this goes off, you hear you will know it. Okay, you cannot but miss hearing it. They will remind you of the fire bell. So again, this is your continuous ringing bell. Okay? And I'll just go up to make sure that you get everything in place, and you can see how it is structured. Okay, in place, in part, fully. I've reduced the magnification a little bit. Okay, so I hope that will help. Okay, I think that's it for now. Okay, and again, I hope you found this useful. Okay, and again, I look forward to speaking with you again in due course. Okay, now remember to look back at the text so you can read the text for yourself. Then go and look at each bell in turn. I'm going to take the time now to go back up and to have a look, make sure you can see what I'm trying to say. I'll pull back a little bit so you can get everything in. Okay, well, most of everything in. Okay, we'll work our way back up. Okay, now remember, this is the polarized bell. Okay, you can see how the north and south magnets has been wound. Now, like poles does what? Repel. Unlike poles attracts. And you should remember that from simple science. Now, this circuit here, again, you can actually build it yourselves with little LEDs, and so if you have 12 volts here, let's say you have 9 volts here, okay, and you need to have a resistor that will give you approximately maybe 10 milliamps flowing through here, assuming that these were LEDs. Okay, R equals V over I. So if you know V, which would be 9 volts, you don't know the current that's flowing, so, and you don't know the resistance, so you'll need a given value. You need to know the value of your LED. Okay. But from what I can remember, putting an LED, a resistor in here would normally be about 100 ohms roughly, if I remember correctly, but don't hold me to it. Because when you push the button, you don't want the LED to blow if it draws too much current directly through it. So you have to have a means of limiting the current flow through the LED. Okay, right, let's go back up. But please note that these are lamps, not LEDs in this case. So let's go back, let's make sure we get everything in. Okay. Yeah, seems like we have everything in, and just make sure everything that we can do is done. Okay, again, I hope you found this useful. Now read the information, write it out for yourself, extract it. Don't just try to read it from the screen. I mean, I don't even know how you guys learn these days. It's unreal. I mean, I got guys coming into a classroom without pen or pencil, and they're doing science. We're doing Ohm's law, or we're looking to calculate the value of resistors in parallel, and these guys they haven't got a pad, they haven't got a pencil, asking me for a pen or pencil. Sorry guys, but you're asking me for pen and pencil, it's going to cost you $5 just to borrow a pen from me. Well, let's just call it interest. And anyway, have a good night. Bye bye.